All right, so I think this is recording. Let's take a look at this word problem. Now, students are going to have to get over the anxiety of word problems, and you're going to have to develop strategies and get good at solving them. The first thing that I suggest doing is that you read the problem probably more than once, that you read it a couple of times and try and gain the best understanding that you can of what it's asking for and what information is given. And then try, most likely, now here a sketch has been provided for us, but if a sketch is not provided, try to make some type of a sketch that illustrates that problem, because maybe you can gain some more insight and understanding what's being asked for and what information is given to figure that out. So here we have Bob shot an arrow from the top of a 336-foot cliff. The arrow's distance above the ground below can be modeled as a function of time in seconds. We have an equation, h of t, and notice that it's a quadratic equation. Remember, the graph of quadratic equations are parabolic, that a parabola, and that negative 16 means that parabola is opening downward. So if you look at our picture, you can see the path of the arrow is a parabolic path, and that's why that this model of a quadratic equation is such a good representation of what's going on in real life with the path with shooting this arrow. So when will the arrow be 560 feet above the ground below? Well, we do have two possibilities. It could be that 560 is the maximum height of this arrow, in which case it would be at its peak, and in terms of the parabola, it would be at its vertex. But I think it's probably more likely that the 560 feet, that after Bob shoots the arrow from the top of this cliff that's already 336 feet in the air, after he shoots the arrow at some, I don't know, maybe 1 second, 2 second, at some later time, that arrow is going to be traveling upward, and its height above the ground is going to be 560 feet. And then it's going to reach some maximum height, like I say, and it could be the 560, and then it's going to turn, and on its path, on its way down, it's going to pass that same height again on its way down. So we're going to look at first to look for two solutions, unless it's a special case of where 560 is the maximum height. So let's begin with, when we look at this equation, the left-hand side of this equation is giving us the height. The height that we're interested in is this 560. So we're going to replace the left-hand side, this function notation, with 560. So we've got negative 16 t squared plus 128t plus 336. So this is a quadratic equation, but we need it set equal to 0. So let's do that, and I'll try not to make a silly arithmetic error. So I'm going to grab my calculator. If I take 336 and subtract 560, I get negative 224. Now, is that divisible by 16? Yes. Is 128 divisible by 16? I believe it is. Yes. So I'm going to divide every term here by negative 16. 0 divided by negative 16 is 0. Negative 16 divided by negative 16 is just 1. And 128 divided by negative 16 is going to be minus 8. And then here I get 14 times 16 is 224. So are there two numbers that when multiplied together give me positive 14 and negative 8? I don't think so, because 14 has factors of 2 and 7, but 2 and 7 add up to 9 and not 8. So I'm going to have to use the quadratic formula. Take the opposite of b, the opposite of negative 8 is positive 8. And underneath this radical is what we refer to as the discriminant. It's b squared, which is negative 8 squared, which is 64, minus 4 times a, which is 1, times c, which is 14. Probably a good idea that I should have written a, b, and c down here for you, or maybe more for me. That way, I won't make, hopefully, a silly error in substitution. All right, so what do we have here? What is this discriminant? Well, it's 64 minus 4 times 14 is 8. All right, now I know how to take the square root of 8. The biggest perfect square that divides 8 is 4, and the square root of 4 is 2. So I know, be careful, you can't come in and cancel terms. You have to divide both terms by 2. Both the 8 and the 2 radical 2 get divided by 2. Students will often make mistakes. They'll have the whole problem correct, and then at the very end, they'll do something silly like cancel terms, and common terms don't cancel, only common factors do in this expression, in this fraction. So let's get it says round to the nearest tenth in the problem. I've got my calculator set to fix to 2 decimals. So if I have 4 minus the square root of 2, I'm getting 2.59 seconds. So in a little bit more than 2.5 seconds after Bob shoots the arrow, that arrow will be at 560 feet, and it will continue traveling upward, and then it'll start to come downward, and make sure that you key in the right values on the calculator. 5.41 seconds after he shot the arrow, it'll be traveling on its downward path, and again it will be passing through a height where it's 560 feet above the ground. So here's our 2 solutions to this quadratic equation. I hope that helps, and I'll talk to you later. Bye.